today, or this lesson here, is part one. Tomorrow we're going to be doing part two with even more word problems, with more scenarios and those advanced type problems. So stay tuned for that. It's going to be a lot of fun, but let's go ahead and enjoy today's class. So we got three main goals. Between today and tomorrow, we have three main goals. Number one, if you couldn't tell by the name of the class, it's unit conversions, and we're going to learn how to convert units. And I'm going to present to you my favorite way to convert units, but I also understand that everybody likes to learn in different ways. So I am going to present a secondary way to look at it in case that helps you even more. So that's number one. You got to learn how to convert units. I think that's pretty self-explanatory. Number two, I'm going to start here first. Avoiding mistakes in common word problems, or common mistakes in word problems. We're going to be looking at a variety of word problems, looking at time conversions, distance conversions, weight conversions, including money. And I'm going to show you how the same principle applies. And also how to spot those potential mistakes that a lot of people seem to make when they're just starting off learning. And the faster that we can go from, making common mistakes to only making rare mistakes, the better, right? So we want that. So again, we're going to learn how to convert units. We're going to learn these common type word problems and how to get through them and how to avoid those mistakes. And then in tomorrow's class, absolutely, we will be looking at, and I hate to say advanced for this one particularly because there's not really anything extra you have to do, but I'm going to show you how a problem that gets a lot of people, that trips a lot of people up, I'm going to show you how you can get those points in the ASVAB. Because remember, on the ASVAB, guess what? You're being graded based on how well you do compared to the other people around you. Not physically in the room. I'm talking about nationwide. But if you are getting a particular problem right and 900,000 people are getting that problem wrong, guess what? That's going to be much to your benefit because you're being graded compared to other people. So you want to learn how to do these advanced problems because when or if they appear on the test, you'll be ready. So let's make sure that we're ready in every sense of the word. So again, three goals: unit conversions, converting them, word problems and common mistakes, and then taking a peek at some advanced level problems to make sure that we have our eggs in the same basket. Boom. So meat and bones. How do you convert units? So long story short, I'm going to keep it fairly simple and straightforward for you in today's class. My favorite method is using a conversion rate. Now, quick question. Has anybody here ever heard of conversion rate? The term or phrase conversion rate. Yeah, you may have heard of conversion, you may have heard of rates, but have you heard of conversion rates? I mean, be honest, because if you have, if you have been raised in the K-12 public school system, you probably haven't learned this. But I'm going to show you a general method that makes a lot of sense for every scenario. So a lot of the times in school, they tend to teach you what the textbook says, and there's little room to actually explore other methods. So I'm not calling any teachers out. It's really the system that's at fault. But I'm going to make sure that we can take this and do a lot of good with it. So pay attention to this, because if it doesn't make sense, I want to understand exactly what mechanism of this that we need to review. I got you. But let's write this down here. To convert from one unit to another, what we need to do in every single circumstance, if you want to convert a unit, simply multiply by the conversion rate. Now, are you always going to have to use a conversion rate? No. If I told you, hey, 60 minutes is how many hours, everybody, what would you say? 60 minutes is how many hours? What would you say? Muhammad? Muhammad, what's going on, man? I haven't seen you in a minute. Sorry, yes, that is the same Muhammad. Well, welcome back, man. Haven't seen you in a minute. But yeah, that's going to be one. And I don't think that many of us need to debate that or write anything down for that, for the same reason that a lot of us don't need to convert 2 feet with math. A lot of us know that if 1 foot's 12 inches, 2 feet might be 24 inches. So when I teach you a method, all I'm saying with this is when I'm teaching you a method, remember that what you already know, I'm not overwriting it. I want you to use this in conjunction with what you already know. And if you're starting from a surface of, hey, I have no idea what's going on to begin with, then this is still an amazing way to start, and it's still going to work out for you. So before I continue, does that make sense? Because I want to make sure you understand where I'm coming from with that. Awesome. Again, if you already have like a nice method for yourself and you've learned this, great. And if you're confused, then let's stick to this. Here we go. First of all, you might be wondering, what the heck is a conversion rate, coach? You keep saying that thing. What's going on? What is it? Long story short, you're basically taking advantage of how fractions work. Everybody, quick question. What happens when you divide the same thing by itself? What happens? Like 10 divided by 10, or y divided by y, or 100 divided by 100, or 17 divided by 17. What ends up happening? Right? You get 1. And another way to say that, because that's absolutely true, you always get 1. But if you have, like, let's say, 5 over 5, and then you draw those lines, what are we talking about there? What idea is that? Right? Canceling out. Canceling out and becoming 1, again, those are the same exact idea. But I'm going to take advantage of this fact that to make your life super easy. Super easy. Watch this. Everybody, let's look at this example here, and let me show you what a conversion rate is. We're trying to go ahead and convert 3 feet into inches in this example. Let me go ahead and just circle that for you to show you where I'm coming from. Convert 3 feet into inches. All right? How do we do that? Well, first, what you're always going to do is start with the unit you have. So let me go ahead and mark that for you. Start with the unit that you have. So begin with the given unit. I'm going to label this so I'm going to detail this for you so much that it's going to make it very easy to refer to in your notes. Okay. So the first thing you do is just begin with the given unit. Then number 2, you're going to present the conversion rate. And again, I'm going to explain what that is in a second. You're going to explain the conversion rate to cancel the old unit and leave the new unit. So let me go ahead and write exactly what that means for you here. So I'm going to just right there. So present the conversion rate to cancel the old and leave the new unit. So I'll give you a couple of seconds to write that down because I want to make sure that you're not trying to write and listen at the same time. It's not going to work out well. So I'm going to give it a few moments, but I'm going to ask a series of fundamental questions that I think anybody in this room can answer so long as you're just using your eyes. So let's go ahead and just do this little exercise here and go through these steps. So again, step number 1, you're going to begin with the given unit. And then number 2, you're going to present the conversion rate. Again, it's being multiplied. Right there, it's being multiplied. You're going to present the conversion rate to cancel the old unit and leave the new unit. Now, let's get into what a conversion rate is. Everyone, I'm trying to go from feet to inches. Is there a relationship between feet and inches that's written somewhere here that is going to be very useful to me? Can you write that down in the chat box, please? What is that going to be? Well, what's written somewhere here that might help me out? Yeah, 1 foot equals 12 inches. That's your conversion rate. Right there. That's your conversion rate. So you already have seen a conversion rate. You know what it is. A conversion rate is telling you, simply put, this many of this unit equals this many of that unit. That's all the conversion rate is. And you have to memorize these. We'll talk more about that in a moment, but you're going to have to memorize those. So right here, that's your conversion rate. So this is your conversion rate. And I'm going to make this as smooth as I possibly can for you guys. I got you. So everybody, what am I trying to do with the old unit? What's that C word I said? What am I trying to do with that old unit again? I'm going to give you a couple of moments here. Yeah, you're trying to, oh, yeah, convert, obviously, duh. You're right about that. But cancel it out. Yeah. Right. Thanks for thanks for seeing that too. But yeah, we're trying to cancel out the old unit so we can leave the new one. So everyone, if we are starting with 3 feet, we're trying to cancel out the feet. We're trying to leave what it is in inches. One more time. I'm starting with feet. So I want to somehow get rid of feet so that way I end up with just inches. Before I continue, does everybody understand the goal? I'm going to show you how to do it in a moment, but does everyone understand the goal? We're trying to get rid of feet and just leave inches. Cool. Here's how we'll do it. Technically, everybody, the 3 feet that we currently have, is it true that we could write 3 feet as 3 feet divided by 1? That's the same thing, right? If I wanted to, if I had some sort of, ghost taken over me, I could write anything over 1. That's technically a fraction. Anything's technically a fraction. Now, that fact is very important for this reason here. If you have feet up top, as you see right here, if I got feet up top, where do I need to put feet to cancel it out? On the bottom. Malik, no worries. Welcome in. But yeah, we're going to have to put it on the bottom to cancel it out. Because think about it. If I have 5 divided by 5, the 5s will cancel out. If I had 72 over 72, those would cancel out. If I had even a variable, x divided by x, that would still cancel out. And so it works with units as well. If I have feet up top and I have feet on bottom, everyone, what's going to happen? If I have feet up top and feet on bottom, those units will cancel out. So you know this from the numerical perspective, knowing that 3 divided by 3 cancels out, 10 divided by 10. You know that. And that same idea transfers over to units. Even if you didn't know that before, I hope that this is starting to gel just a little bit now. So here's what you're going to do. I want to get rid of feet. So here's my conversion rate. Great. I got 1 foot. I'm going to put that in the denominator because I want to cancel out the feet. And then I'll put the 12 inches up top. Everyone, here's what happens. Technically, remember, this is up top and this is on bottom. So we can go ahead and cancel those out. And now what we have left is simply this. We simply have 3 times 12, and that's going to be 36 inches. And let me just write this out for you and talk a little more about this. Right there. Boom. So as you're writing this down, I want to see how well we understood this. So I'm going to ask, again, a series of leading questions to see where your head's at right now. So quick question for everybody. Please go ahead and respond in the chat box. Please and thank you. So as we begin this, does everybody understand, first of all, the goal was cancel the current unit that we have so we can get the unit that we want? Yes or no? Excellent, excellent, excellent. I'll give it a few more seconds. Okay, great sign so far. Boom. Now, to achieve that goal, again, we got to cancel the old, get the new. And do you understand that when you look at this from the perspective of a fraction, which anything can be a fraction, do you see that if you start with a current unit, when you see the conversion, you put that unit on the bottom to cancel out the old unit? Oh, we'll talk about all the conversion rates in a second. I got you. Okay, great. So again, by technicality, the old unit starts off on top. So when you have your conversion rate, like your 1 foot equals 12 inches, I'm trying to cancel out feet. I'm gonna put that 1 foot on the bottom. That's it. And then if I want to leave inches, I want inches left over. Boom, the 12 inches, that goes up top. And so technically this becomes multiplication because you see that the 3 is on top, the 12 is on top. So that becomes 3 times 12. And that's how it's left at 36 inches because the feet canceled out. That's it. So on a scale of 1 to 10, how much sense did that make for you? Or do you need to see a few more examples before this fully gels with you? Because I'm assuming that it will. I'm assuming that it will. Cool. And even for those of you that are saying that you're confused, again, still very expected. I'm going to show you the difference between, okay, this led us to multiply. In other instances, to convert, you might need to divide. And has anybody here ever asked the question, coach, or in your head, how am I supposed to know when I'm supposed to multiply or divide that conversion? How am I supposed to know when to multiply or divide? Has anybody ever asked that? Right? That's the question of the year. That's the question of the year. And this answers that question. If you follow the conversion rate, you'll be able to tell full and well whether you're going to be multiplying or dividing. So let me show you how. Let me show you how. Here's another example here. The example says, hey, convert 32 ounces to what, everybody? State it in the chat box, please. Convert 32 ounces to what? Exactly. Convert that to pounds. Perfect. So, with that said, we're starting off with 32 ounces. Everybody, we're trying to eliminate ounces. What should I write? Right there. Excuse me. Wow. Whew. There we go. There we go. There we go. There we go. So remember, what we're trying to do is we're trying to go from starting with ounces, we're trying to just leave pounds. So everybody, which unit are we trying to cancel? We're starting with ounces. We're trying to get to pounds. What are we trying to cancel out right now? We're trying to cancel out ounces. So all I'm going to do, you have to know this fact here. You have to know that 1 pound is 16 ounces. You have to memorize that. And once you memorize it, apply the strategy and you're good. Because watch, boom, 16 ounces goes in the bottom. Everyone, what am I going to write up top? What am I going to write up top? 1 pound. Again, this right here, that 1 pound over 16 ounces, you're not doing anything to the actual number that you're dealing with, the actual value. 1 pound is the same thing as 16 ounces. You're technically multiplying by 1. That can technically cancel out, but you're actually just navigating a slightly different way, and you're going to be doing this. Oh, ounces and ounces, boom, cancels out. And what you can see is that this leads you to divide, because what you have right here is 32 times 1. So that's just going to be 32. And then in the denominator, you still have 16. So you got to put that 16 down there. So that's why, and that's how you can guarantee that you'll know that this is now a division problem by just following that conversion rate. And don't worry, we're going to go through plenty of examples before I let you do it on your own. But I want to make sure you understand how this works and how convenient this makes your life. So, quick question, everybody. What's 32 divided by 16? That's going to be 2. 16 times 2, that's 32. Hopefully, we have enough practice with that. And if you didn't, don't worry, stay along for the ride. That's going to be 2 pounds. Because remember, the unit that you have left over is right there. 2 pounds. So I'm hoping I'm starting to, you're good. So I'm hoping I'm starting to answer the question again. How do you know whether you're supposed to multiply or divide? If you start practicing using this general method, and again, there are plenty of other methods, but this is a surefire method no matter what, because all you have to do is memorize your conversion rates and then place the unit you're trying to cancel on the bottom. That's it. Place the unit you're trying to cancel on the bottom, the one you're trying to get to up top, and you're set. And you're set. We'll definitely look at a few more examples, Kayla. I got you. But does this example make sense? Do you see why here we divided and here we multiplied? Are we starting to see why, everybody? Who created mathematics? I don't know, probably one of my ancestors. But cool. Oh, Malik, if we're getting to historical mathematics, man, let me tell you about this class I took in college. It's called the History of Mathematics. So Babylonian mathematics, Mayan mathematics, the mathematics in the Arabian Peninsula. My God, they were more advanced than anybody else. The Romans jacked a lot of the world's math, but that's neither here nor there. But with that, let's go ahead and look at a few more examples. Let's take a look at a few. I got you, Damien. Let's look at a few more examples here. I got you. So let's go ahead here. Let me go ahead and show you this here first. So everyone, let me go ahead and just focus on the U.S. customary units. You're going to need to know all of these, but I'm going to start here. Go ahead and take a screenshot of this. If you're on your laptop, go ahead and use your phone, take a picture of it. You know how you can go ahead and just copy and paste everything after anyway. But go ahead and take a screenshot of this because we're going to be applying this and do a few examples coming right after. Yeah, definitely got you with the examples. So things you're going to need to know, guys. Like if you're going to sit here and hopefully, I'm going to say this lightly. It's cool. It's okay to complain. It's not cool to complain, but it's okay to complain. What's not okay is complaining and then not doing what you're supposed to do. Okay. If you're going to complain because you're doing the right thing and it just sucks. So let's go ahead and get through it together. When we're talking about units of length, you need to know, hey, how many inches are in a foot? You need to know how many feet are in a yard. You need to know how many feet are in a mile. And it would also help if you knew how many yards are in a mile, but you may not need to know this one, but I have seen examples of some rare problems where they have you do that, but you can still figure it out without that. But you want to know these. These are common. You want to know these. Now with weight, you need to know and memorize that 1 pound is 16 ounces. You need to know that 1 ton is 2,000 pounds. There's no ifs, ands, or buts about it. If you know how to work the conversion rate, but you haven't memorized your conversion rates, that's on you. If you memorize your conversion rates and you're having trouble actually applying conversions, might be on me. So let's go ahead and make sure that nothing is left on your shoulders. Do everything you need to do, okay? Next up, when we're talking about capacity, so measurements typically in cooking, but you have 1 cup being 8 fluid ounces. That's rarely going to be used, but still important to know. 1 pint being 2 cups. Again, not used as often, but you're going to want to know it. 1 quart is 2 pints, and 1 gallon is 4 quarts. This one is used a lot more often. Let me go ahead and highlight the ones that you're definitely going to want to prioritize over the others. But again, it's not that hard to memorize them all. So here, you're going to want to know this one, and this one. These are the ones you want to prioritize. Like these are the most common examples. But again, take that with a grain of salt. You want to know all of them. I'm just telling you what the most common examples are. And then on top of that, if you're looking at time, there is no excuse. You need to know all of these. Every single one of these. You should know these naturally. If you didn't know this, man, you should be excited. If you didn't know these common time conversions, you should be excited because that means that there's a lot of easy points in the ASVAB that you're going to be able to get. So don't feel ashamed. Be excited about it because, again, you can't control the past. You are where you are. Let's just go ahead and focus on moving forward. Yeah, time is the most common one. That's the one we use the most often. So it's all good. Hey, Ellie, you're welcome. So everybody type into the chat box. Type ready when you're ready to proceed into doing these next few examples. Listo. What does listo mean? Are you speaking Spanish in my classroom? ¿Estás hablando español en mi clase? Bienvenidos, soy señor Durán. Vamos a aprender matemáticas en la forma del ASVAB. Let's get to it. So here's some examples, my party people. Yes, I speak Spanish. And ich auch spreche Deutsch. Whoever knows that, type it in the chat box. So here we go. Let me go ahead and show you guys some examples. Let's have some fun. Yeah, that was German. Yeah, so I speak English, Spanish, and German. So here we go. Let's get started right over here, everybody. Let's start with, let's turn 6 feet into inches. And then this next example, let's go ahead and turn, let's take a look at 48 inches. Let's turn that into how many feet? Let's take a look at these two examples, okay? Let's take a look at these two examples. And no need to use the sweating emoji. I use Duolingo. It's very easy to use. I've been using it for a few years. So with that, 6 feet converting into inches. Let's talk about that one first, the one up top. Everybody, for both of these, if you haven't noticed, we're converting the same units. We're converting inches and feet. So it looks like we're going to have to memorize and regurgitate that conversion rate between inches and feet. Would you all kindly, in the chat box, go ahead and type out what that conversion rate is? We're going to just lower that just a little bit there. Perfect. Yeah, 1 foot equals 12 inches. Everybody go ahead, type that out in the chat box. I don't care if this is your millionth time doing this or your first time. Go ahead and participate because you guys understand. Well, most of you guys understand that have been in my classes. The more you participate and communicate, the better, the better it ends up being for you. So great. You need to be able to regurgitate that in your head, and you got to know that 1 foot equals 12 inches. Perfect. Now, here's how, again, we're going to be using the same conversion rate for both problems, but this is going to answer the question for you. Coach, am I supposed to multiply or divide? Here's the first one. We got 6 feet. Remember, you're always multiplying by that conversion rate. Everybody, what should I put up top in this conversion right here? What should I put up top? Yeah, we're going to be putting inches up top because that's the value or the unit that we want to end up with. So boom, I see that again, between feet and inches, 12 inches is 1 foot. So I'm going to put 12 inches right here. And then, again, I'm getting away from feet. So I'm going to put that 1 foot right there on the bottom. Because look at what happens here, everybody. This makes it clear to us now that, again, I'm taking away feet so I can leave inches. Again, that's exactly what I want. And now this clearly leads me to multiplication. I'm going to have 6 times 12, and that's going to end up being 72 inches. But that clearly lines up multiplication. Now, if we take a look at the difference down over here, we have 48 inches. How many feet is that? Everybody, we have the same conversion rate. This time, though, what are we going to put up top on that fraction? This time, what are we going to put up top? And be specific, not just one, not just foot, not just feet. Put it together here. We're going to put what? Exactly 1 foot up top. We're going to put 1 foot up top. And then what are we going to put in the denominator? What are we putting on bottom? Yeah, 12 inches. So again, look at that. The same exact conversion rate used a different way. All you have to do is observe, hey, what unit am I starting with? Because I'm trying to get rid of that unit. And so that'll dictate whether you put something on the top or the bottom. That's it. That's all it is. That's all it is. It's going to make your life so much easier. So boom, 12 inches. Because look right here, inches on top, inches on bottom, bam. And all you see now is that this is division. We have 48 up top and 12 on the bottom. So that's division. 48 divided by 12. What is that, my party people? That's going to end up being 4. And that is 4. What's your unit there? Feet. Boom. And you're good. So with that said, does that make a little more sense than it did before? Okay. Yep. Again, be honest. Please be honest. I see a lot more yeses this time. But I also see those no's. So we're going to do a few more examples before we start getting into those word problems. And I've already planned to spend until 7:05, 7:10 just on the pure unit conversions. So we're good. And also remember, again, if you're in the program or the trial, write this down. You're going to be looking at Unit 3. Unit 3 in arithmetic reasoning. That's exactly where all of this is going to be. All the practice and worksheets, speed drills, everything you need, the lessons, it's all there. So even if through all the methods that we look at today doesn't quite totally make sense, I do teach other methods that still work out perfectly fine in Unit 3 of arithmetic reasoning, okay? So let's go and keep practicing here and let's see what we got. But let me answer some of these questions here. So let me see here. So Socorro, it's not always division or always multiplication. It's going to depend on what unit you start with and what unit you want to end up with. So let me go ahead and go through a few more examples here because I got you. So let's go ahead and start with, let's say we have, I want to turn, let's say 5 minutes, and I want to turn this into seconds. So can anybody here, first of all, again, the first step is going to be remember your conversion rate. Let me write this down on the side for you. Step 1, conversion rate. And step 2, we're going to go ahead and place the one that we want to eliminate on the bottom. So remember your conversion rate. And then worry about the placement, okay? First, remember the conversion rate, and then worry about the placement. So what I mean by remember your conversion rate is just take a look at the unit you have and the unit you want. Okay, I have minutes, I want seconds. Everyone, can you please state clearly in the chat box, all the ways you can you give me the relationship between seconds and minutes? And even if you're confused from the previous examples, you should be able to do step 1. You should absolutely be able to do step 1. Can you tell me what the relationship is between seconds and minutes? And I want everybody to answer this one there. And Kayla, I remember you saying you wanted to ask a question. Go ahead and state it. Yeah, so Delilah, the other way that I teach, and everybody, you don't have to pay attention to this, but the other way that I do teach is if you're going from a big unit to a small unit, you're basically breaking that big unit up into a bunch of smaller units. And so you multiply to do that. When you're going from a small unit to a big unit, you're grouping up and dividing. You're seeing how many groups you can make. So you're dividing. So big to small, you multiply, small to big, you divide. But that comes from this. That comes from this general teaching. So I want everybody to focus on this general teaching here. Okay, cool. So I see here. Great. 60 seconds equals 1 minute. So let's write that down, everybody. 60 seconds equals 1 minute. Boom. That's what I got. Sounds good. Now with that, we're going to go ahead and apply this now. Everyone, I'm starting with minutes. So where should I place 1 minute? Where should I place that? On the bottom or the top, my party people? Where should I place that? And I want everybody to answer, even those that were confused. Because remember, what I said was, I'm trying to cancel this out. I'm trying to cancel that out. And remember, technically, this is up top because you can write this as 5 minutes over 1. So again, if you don't see a fraction, assume it's up top. Assume you're starting with it up top. Yep. So with that said, boom, I'm starting with minutes. So I want to get rid of minutes. So see how many seconds it is. So with that, bam, I'm going to put the 1 minute on the bottom. Because remember, what's going to happen is it's going to cancel. If you have the same thing up top and bottom, it's going to cancel. And so you're going to be left with the 60 seconds up top. And so everybody, Are the 5 and the 60 here being multiplied or divided? Are the 5 and the 60 being multiplied or divided here? And there you have it. And so here, boom, we're doing 5 multiplied by 60. And everybody, 5 multiplied by 60. Boom. That's going to give you 300. And so here's what I'm going to say about this. So this is going to be 300 seconds. Let me put this in purple. So here's the great thing about this general method. The great thing is you don't need to worry about, hey, am I supposed to multiply or divide? Because if you place the unit you're trying to get rid of to cancel out on the bottom and the unit that you want to end up with up top, it'll reveal itself no matter what. It'll reveal itself no matter what, like it did here, like it did there, like it did there. Yes or no, guys? Is that making a little more sense in terms of, hey, how do I know if I'm supposed to multiply or divide? Again, when you set it up, it'll reveal itself. So I don't want you guys assuming that it's always going to be multiplication or assuming it's always going to be division. I want you assuming that. Cool. Sounds good, Damien. Another conversion there. Deja, sounds good. And again, it's going to take time to completely understand it once we see all the examples, but I'm really happy that we're going in the right direction. So I want to give you guys a few more examples here, and I want you to try these out on your own. Now, I want to ask this first to make sure that you have this written down. Everyone, can you give me quickly the conversion rate in the chat box? Type this quickly. Can you give me the conversion rate for feet and yards? Go. Feet and yards. Go, 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 go. Give me that conversion rate in the chat box. Feet and yards. Excellent. 1 yard equals 3 feet. 3 feet equals 1 yard. Yep. Either way. No. 1 foot is not 3 yards. No. 1 yard is 3 feet. 1 yard is 3 feet, or 3 feet is 1 yard. Either way. But there's that. Okay. Now, before I give you these practice problems, I'm going to show you where that's from again, just to prove the point. Right over here. 1 yard equals 3 feet. There it is, right there. Now, I want you guys to notice something about this real quick before we continue. Does anybody here notice something odd or a pattern here, with all of these conversions? Anybody notice anything particular about every single conversion? Every single one has something in common. Right. In every single unit conversion, every single one of the units is a unit. One unit, non-plural, singular, means one. So you're saying one of these is that many of those. One of these is that many of those. One of these is that many. It's always one. So this is what makes life so much easier, because if you have the 1 on the bottom, you don't have to worry about it. When you divide by 1 at the end of the day, it's going to stay the same. So that's why you can just go straight to just multiplying. And likewise, or similarly, when you have that 1 up top, that's being divided by this. So you're saying 48 divided by the 12. That 1, you don't have to worry about it. It makes life so much easier because it's a number, a placeholder that you don't have to actually calculate, because multiplying or dividing by 1 doesn't change the number at all. So that's what it's going to tell you. If the actual number, not the 1, if the other number's on the bottom, you're dividing. If the number's up top, you're multiplying. And that's what's going to give you that sense of calm in terms of, hey, am I supposed to multiply or divide? That's what's supposed to give you that sense of calm. So with that said, are you guys down to try a few examples out? Hey, no worries. If you have a question, go ahead and ask it now. I'm more than happy to answer it, and we'll keep moving forward from there. Again, guys, ask questions. I got your back. And then after we do this practice, I'm going to give you a shortcut method. I'm going to state it in a sentence. I'm going to write it down for you. You guys already heard it in terms of, hey, big to small, multiply, small to big. I'm going to state that for you and explain what that means. I see Dominic is using Google Translate. All right, sounds good. So with that, let's go ahead. Oh, Cassandra. So all I was saying was just in terms of knowing when you're supposed to multiply or divide, the one is going to make things a lot easier because it's always 1 unit of this equals this many of that. So as long as you place things in the right way, you're going to see whether you need to multiply or divide. So the last sentence I said was, if the actual number is up top, you're multiplying. If the actual number's on bottom, you're dividing. That's it. Well, since Dom is using all caps, we must believe him. Okay, I got you, man. Sorry about that. So with that, let's go ahead and practice here. Oh yeah, we'll practice with decimals. I just don't want to freak everybody out just yet. So here we go. Let's look at some examples here. I want you guys to start off by doing some of these. We're going to do so 12 feet equals blank yards. We're going to have this up next. We're going to have 6 yards equals blank feet. We're also going to have cool. And I want to give you guys an opportunity to go ahead and try these 3 conversions out. I want to give a timer. I'm going to put 2 minutes. That should be enough time to at least try 1 or 2 of them. But I want you to just do your best, okay? I want to see how far you can get on your own. Because when we start looking at these problems with the word problems, you're going to see how this comes into play. This is going to happen in every single unit conversion problem. But the more that we do this now, the less you'll actually have to write down those conversion rates. With practice, you'll be looking at this and you'll be like, okay, divide by 12, multiply by this, multiply by that. You'll be able to tell. But for now, we must write things down to get into the flow of things. So let me go ahead and get that timer up for you. 2 minutes starting there. And I should have this pop up about now. There you go. Oh, so Remy, that's 1760, 1,760. That was yards. So just making sure I clarify that for you, Remy. I got you. I see some of you guys private messaging me what you're doing. I like it. I like it so far. My answer to everybody is yes, who has private messaged me. Mackinson? No, not quite. Close. Hey, Krishan, no worries. No worries. We got 30 seconds here. Again, what you want to do again, you already have that beginning unit set up for you. Then the next thing you need to do is set up that conversion rate. McKelvin, I'm glad it's feeling easier for you after that tutorial. Now let's continue supporting our classmates and make sure that we're all in this together, right? So we have 10 seconds left. Let me go ahead and just set up the fractions for all of us. Okay. So time's up. Let's go ahead and try this out. So before I begin, how are you guys feeling about getting these done on your own? Do you feel like you were able to do more on your own now than you were before, or you feel like you're still just as confused as when you were before class? How are we feeling? So some of us are still a little bit confused. A lot of us are feeling a little better. Okay, still confused, much better. Okay, cool. So let's go ahead and take it one step at a time. I got you. One step at a time. So first things first, to set it up, all you want to ask yourself first is what's the conversion rate? So let's see if we can get that part done first. This first problem here, feet, yards. Can everybody tell me what the conversion rate is between feet and yards quickly? Yeah, so 1 yard, 3 feet. Let's write that down there. Again, step number one. We got to make sure that when we set up our conversion rate, we know what the conversion rate is. So here, 1 foot equals 3 yards. So for everybody here who said that they were confused, everybody who said that they're good and knew this, so just don't answer this question. For those that are confused about unit conversions right now, let me talk to you specifically. First off, are you good on that? Are you good with knowing 1 foot is 3 yards? Again, only for those that are confused. I want to make sure. Okay, so for those of us that are confused, okay, remember the conversion rates; those are non-negotiables. Those are just those are mathematical facts. You want to memorize that. Okay, so I have no control of that. This is what I have a little control over, and I can teach this a few different ways. But let me show you why this general method, again, it's really convenient once you get used to it. So this is again only for those of us that are confused. Everyone in this first problem here, for those of you that are confused, what unit are we trying to get rid of? What are we trying to get rid of? Right, we're trying to get rid of feet, right? Because we're starting with feet and we're trying to end up with yards. So we got to get rid of the feet. So what that means is if I'm trying to get rid of it, put whatever the foot part of the unit conversion, put that on bottom immediately. So when you see right here, boom, 1 foot, and then you have the 3, or excuse me, wow, did I really write that? Let me fix that up for us. 3 feet equals 1 yard. Wow, mistake of the day. Mistake of the day. So with that, we have 3 feet is 1 yard. So we're going to go ahead and put that the right way. That was funny. I'm going to remember that one. We have 3 feet right there, and we have 1 yard here. That is hilarious. So when you check this out, let's just backtrack a little bit here. We said we're just trying to cancel out that old thing and leave the new. And if you check this out, you have this up top, this on bottom. What technically always happens when you're dividing the same thing by itself, this cancels. That's what ends up happening. So I want you to start understanding that when you have something in the denominator and up top and the numerator, it's going to cancel out. And so for my party people that, again, for those of you that specifically were confused, do we see why in this situation, we would put the yard up top and the feet on bottom to cancel out the feet? But in this situation, in the second problem, it's a little different. It's the same unit conversion, but look, I'm trying to get rid of the yard. So I'm going to put 1 yard on bottom because that's how I'm going to cancel it. Are we starting to see that a little better there? I'm talking to Cassandra, Kashan. I want to see if you understand just the idea that we're working with. Cancel out the old to leave the new. Cancel out the old to leave the new. Let me know if that makes sense, guys. Right there. Cassandra, great way of putting it. Great way of putting it. Always put the same name on bottom. Yeah. And I'm gonna let that slide for now, because again, there's crazy advanced situations that you don't have to worry about at all right now. You don't have to worry about it. But to learn this, I'll let that slide for now. It's okay. Yeah, Abimail, yeah, the key is memorizing the conversion rate. And Caleb, yeah, feel free. Go ahead and type that question out. I got you. And while you type that question out, I'm going to keep looking for your question, Kayla. But let's go ahead and go through this. Oh, if you did, can you go ahead and please copy and paste it for me? I may have missed it. I'm sorry about that. But if you could, please copy and paste it. But here, you're going to have 12 up top, 3 on bottom. So everybody that was confused, help me out here. With that 12 and that 3, are we multiplying them or dividing them? Are we multiplying them or dividing them here? No question marks. Go ahead and give it a shot. Again, if you're right, you're right. Great. If you're wrong. We'll correct it. Yeah, here it'll be dividing. Because notice how you have the 12 feet, and on the bottom you have 3. Everybody, if you have a number on the bottom, that means you're dividing. If the number's up top, that means you're multiplying. So because the 3 is on bottom, we are dividing. Again, because it's on the bottom. Because it's on the bottom. So with that said, booyah, 12 divided by 3 is what, my party people? 12 divided by 3, yeah, that's going to be 4 yards. Now, if we take a look at the 6 yards problem here, take a look. The 3 is on the top. So we have 6 and then 3. Everybody, in this case, because the 3, the number that we're looking at, the actual number, is up top, are we multiplying or dividing? Yeah, we are multiplying. We are absolutely multiplying. And so with that, everybody, 6 times 3 is going to give me what? 18. That's it right there. 18. Exactly. Exactly. Yeah, Cassandra, go ahead and type it out. I got you. Malik, I'm glad. And then Aaliyah, I think your question right over here. So you divide if the bottom number is bigger than the top number. If you have the bigger number on the bottom, yeah, you would be dividing it. That's another way to look at it. That would work. Yeah, exactly, Krishan. The 3's on top, so you would multiply it in this situation. And then the 3's on bottom here, so you would divide it in that situation. Yep, absolutely. I'm glad it makes more sense, guys. I'm glad. Let's take a look here. Let's take a look at this one here. Everybody, this one here is going to be a lesson to stick to the idea, stick to the concept. Because everybody, what would you wish this was? Do you wish this was dividing or multiplying? Because here's the conversion rate. Let me write it down for you. Your conversion rate is going to be 1 pound equals 16 ounces. So in this case, everybody, would your mind might tell you, would I rather do 32 times 16, 32 divided by 16? Which one would you rather do, multiply or divide? Right. A lot of us would wish that it's dividing. And if you kind of look at this in terms of the problem that we did earlier, it was 32 ounces was 2 pounds because you divided it in that sense. But you can't go off of pattern. You can't go off of that. You have to go off of what works, like what is true. And what is true here is, everybody, what am I going to place on the bottom here? In this problem, what am I going to place on the bottom in that fraction? The pound, exactly. Because I start off with 32 pounds, so I need to get rid of pounds. I'm trying to get rid of that unit. I'm trying to turn pounds into ounces. So what I do, bam, I got 1 pound on the bottom. And then the 16 ounces up top. Now that I have that, everybody, what's been revealed? What operation am I doing? Am I multiplying or dividing these two numbers together? Yes, I'm starting to see some people that were confused answering with absolute certainty. Here it's going to be multiplication. because you have the 32 and 16, that 16's up top. Boom, that's going to be straight up multiplication. And likewise, because you have pounds up top and pounds on bottom, that's what cancels out, leaving you with the ounces exactly what you wanted. Exactly what you wanted. Now, if you're looking at this, are you happy about multiplying 36 and 16 or 32 and 16? Are you happy about that? Maybe, maybe not. But again, I'm just a messenger. It just so happened to play out that way. You can't hope for more convenient situations and hope that doing it this way makes it easier. Making it easier doesn't mean it's always going to be correct. Okay, you have to go with what's factually supposed to be done. And so, with that said, 32 times 16, we can go off on the side and do that. And then we just go off and do multiplication as normal. So here, I will go ahead and do 2 times 6. That's going to be 12. 3 times 6, that'll be 18. Carry the 1, that's 19. Put the 0 right there. Then we have the 32 times the 1. So 2 times 1, 3 times 1. We add this together, and we have 2. 1 for 11, and then 4. Oh, excuse me, 5. 512. Boom, right there. And we have 512 ounces. It's all good, Remy. I made a slight mistake right there at the end, too. I caught it, but I made a slight mistake there, too. And there we have it. So never, we can do split and glue too, Glenda. That's right. But, never mind the difficulty of the calculation, which you should always be looking to set it up the right way before you calculate, before you do any hopeful calculating. It might seem convenient to do the division. It might look like it's convenient, but if you set it up the right way, you'll see the truth in what's supposed to be done. Okay, so 717 at this point. Yeah, and so the thing is, because remember, this is not a topic that's in the math basics from the very, very get-go. You're going to have to go ahead and practice the other fundamentals first before this is going to be totally, totally, totally within your tool belt. So again, for those of you that have accepted that free week in the program, or if you're already in the program, again, make sure that you are following through on those fundamentals, because once you get to this point, boom, we're memorizing these unit conversions, memorizing that mechanic, that mechanism. Okay, fraction, top and bottom, that's it. Eliminate the old, get the new. But with that said, I'm going to give you now that shortcut that I promised you. So that way, for those of you that are still confused, we can try to use a different or alternate method. Let me go ahead and write this out here, and let's see if this makes sense. So, alternate unit conversion idea. So another way to look at, or another way to convert units. So first of all, you still need your conversion rate, okay? You still need your conversion rate. And then here's the kind of shortcut method. But again, if you know how this up here works already that I've been showing you, then this is going to make a lot of sense, and it's going to help you cut corners and take less time. And even if that all didn't make too much sense either, if you want to memorize this will still give you some sort of reprieve as you continue working on that, okay? So here's the idea. Once you know the conversion for the problem that you're doing, you're going to make a decision. If you're going from a big unit to a small unit, so if you're going from a big unit to a small unit or smaller unit, you will always multiply. So if you're going to a smaller unit, you will multiply. If you are going from a small unit to a bigger unit, notice how I'm underlying to a blank unit. That's really what's important here, because it's all relative. So if you're going to a bigger unit, you are going to be dividing. And I'm more than happy to explain what this means and how to really kind of engage with this visually. I'll show you an example for this. Oh, so Corey, that's all it was. You're just doing it. You had them all good, but you're just doing it backwards. Okay, I'm glad we found that. Now it's time to work on, reversing that misconception. I got you, Cassandra. And here's the thing, Cassandra. So I want to make sure that we all understand why I kind of do this thing where I hold back on giving you guys like shortcuts or secret tricks. I don't know if you guys have noticed this. Like in my classes, I don't really do a lot of that. And the reason I don't do that is because it takes away from the experience of learning. And if I take away from the experience of learning, it's much less likely that you'll actually understand what you're doing. Because when I give you these shortcuts are based off of the general ideas, the general principles. So if you have a good foundation of what we're talking about, when I give you the shortcut, you'll be like, oh, I see where that's coming from. But if you haven't had that foundational teaching or that time to practice it, then if I give you this, sure, you'll be jacked up in class. And you'll be like, man, this works. But the moment that you're by yourself, you'll be questioning yourself every single problem. And that's not what I want. My goal is to have you be self-sufficient in your studying. That way, it doesn't matter if you're attending a live class or not. You are still in good hands because you have built this up. So let me show you. I appreciate that, guys. But let me go ahead and show you how this looks. In all of the examples that we just did, let's go ahead and showcase it. Before I do that, everybody in the chat box, type the answer here. Quick, if I'm going from a small unit to a bigger unit, what do I do? From small to a bigger unit, what do I do? Type it out, type it out, type it out, type it out, type it out. All I got to do is read there. If I'm going from a small to a bigger unit, we're dividing, correct. Now let's reverse it. If we're starting with a big unit and we're trying to see how many of these small units make it up, we are going to multiply. Yep, starting from a big unit to a small unit, we multiply. Cool. So let's see all of this play out. I'm going to show you how all of this plays out here. Let me zoom out just a little bit. And let's start from the very beginning here. Everybody, in this first example, there's so much clutter, but still, we're starting with feet and we're converting to inches. Everybody, from feet to inches, I'm going from a big feet to smaller unit inches. So what am I supposed to do again? What am I supposed to do? From starting with feet and I'm going down to inches, right? I'm supposed to multiply. Is that what happened here? Is that what happened here? Huh. Okay, let's, coach, you got lucky. You got lucky. Are you sure? Let's go ahead and see here. All right, so here we're converting 32 ounces to pounds. Okay, everybody, we're starting with ounces, and we're trying to see how many pounds that is. An ounce is smaller than a pound. So we're going from a small unit to the bigger pound. So if I'm going from a small unit to a big unit, what am I supposed to do again? Oh, I'm supposed to divide. Is that what happened? Yeah. That's exactly what happened. That's exactly what happened. We ended up dividing because we had 32, the 16 on bottom, and boom, we ended up getting 2 pounds. Okay, let's go ahead and see if it still matches up, guys. Let's make sure we're not crazy here, right? So here, starting with feet, and we want it to go to inches. Everybody, from feet to inches, what are we supposed to do? We're supposed to multiply. What do we end up doing? 6 times 12, right over here. 6 times 12. And we end up getting 72. Okay. Over here, starting with inches, going to feet. Starting from a small, going to a big. What are we supposed to do? Supposed to divide. Is that what ended up happening? Is that what ended up happening? Yeah, absolutely. That's exactly what ended up happening. Okay, let's keep looking. Let's prove the point. Let's keep proving the point because I want to solidify this for you. Again, we had that foundation set. Now we're going to see if this shortcut really helps us out. We got 5 minutes. Okay, we have minutes. And minutes by itself, everybody, I want you to pay attention to this. Minutes by itself does not make it a big unit or a small unit. I want you to get that out of your head. Minutes by itself does not mean big or small. Just like feet by itself does not mean big or small. You got to think about what unit you're going to. So here I'm starting with minutes, and then I'm going to seconds, because minutes is bigger than seconds. So I'm going from a big unit, minutes, to a small unit, seconds. What am I doing? Multiply, exactly. Because I'm breaking up a minute. Every minute that I have, I'm breaking it up into 60 seconds. Every minute breaks up into 60 seconds. So it multiplies. Every minute multiplies into 60 seconds. Boom, multiply. Next up, okay, I'm starting off with feet, 12 feet. I'm trying to get to yards. So here's a foot, here's a yard. So everyone, the foot in this case is the smaller unit going to a yard, which is the bigger unit. Notice how if it was feet and inches, feet would be the bigger one. But if we're going from feet to yards, feet is actually the smaller one in this case. Do you guys see where I'm coming from with this? Why I'm really exaggerating this because I need to make sure you understand this. It's all relative. You got to compare the two units. Which one's the smaller one? Which one's the bigger one? We have to make sure we understand that. So in this case, feet to yards, what do we do? What operation? If we're going from feet to yards, remember, a yard is a lot bigger than a foot. So if you're starting from a foot, that's a small unit. Going to a yard, that's the bigger unit. So we are actually supposed to be doing division. And that's exactly what you see here. The 3's on bottom. 12 divided by 3, bam. That gives you 4. Krishan, so you see this, right? This is helping you identify mistakes in real time. Because I don't want to have to explain every single time why it's wrong or right. I want to get you to the point where you can say, did that follow the main idea? Did that follow the principles that we're learning right here? Oh, it did? Great, cool. Then it makes sense. Oh, if I didn't follow my principles, then I can see why I'm wrong. And I want you guys to get into that mode right here, starting with yards, trying to go to feet. Yards, feet, big to small. Everybody, what operation is that? Going big to small, big to small. Check those notes. Yep, that's multiplication. And so we already went pounds and ounces. But in this case, I'm trying to go from big pounds to smaller ounces. That's going to be multiplication, which is exactly what we did. Boom. So I'm going to show you guys the conversion table one more time. I got you. Yeah, well, I got you. So here's the conversion rates that we're going to want to know for today's class. Obviously, there's more when it comes to centimeters and grams and liters and stuff like that. But feel free to take a screenshot of this. The green highlight means like those are non-negotiables. You must know those if you expect to pass the ASVAB. The ones that are not highlighted, they will still appear. They can still appear. But I want to make sure that, if you're like in a rush or if you want to feel a little more grounded in terms of like, what should I prioritize first? The green. Cool. So with that said, everybody in the chat box, let me know how you're feeling right now. Yeah, you're welcome. So in the chat box, let me know how you're feeling right now after doing all of those exercises. Are you feeling better, worse? Do you want more practice with this? Are you ready for word problems? How are we feeling? Okay. So here's what I want to do. I want to go ahead and transition into word problems, but don't worry, because we're going to tackle word problems that I know we can handle. Trust me, trust me, trust me. I've set these problems up. I've set these classes up. I've been doing this for 4 years now. I know we've done this a ton of times. I want to lead you through some fundamental and introductory word problems that you may very well see on the ASVAB. Like, these are problems that you should expect to prepare for. I'm not going to sit here and say that you're going to see it word for word. They may be worded a little differently, but the ideas are going to be the same. converting a unit within the context of a word problem. You are guaranteed to see those on the ASVAB. I want to make sure you know how to handle the introductory ones. So before we get into it, everybody, if you have ever heard me speak before this class before, what's the first thing you always do with word problems? Appreciate it. Yeah, first thing you always do is read the question. First thing you always do. We got to read that question, make sure you know what you're doing here to begin with. What am I trying to do? Let's go ahead and have some fun now. So over here, let's go ahead and start off here. This one, again, not going to be terrible, but let's start off by reading the question first. Question reads right here. How long will the connected envelopes be? So that may or may not tell us exactly what we need to do, but everybody, is it true that if I read the question, just the question, how long will the connected envelopes be? Does it sound like two envelopes were connected and we're trying to see how long it is now? Common sense. Does that sound like that's what's happening? Right? Somewhere, somehow, some envelopes got connected and we're trying to see how long it is. And if you look at the answer choices, 10 inches, 9 inches, 3 inches, and 1 foot, and 9 inches. So we want to connect two envelopes and we want to see how long it is. That's what I want. Got my envelope right here, plus this envelope here. That's all I want to do. Got to figure out how much it is connected, how long it is connected. Let's go ahead and read through the information. Let's see what we got. What do we have to work with? What can we write down? What can help us figure this out? Let's go ahead and do that. So here I see, again, I'm looking at what I have. It says Matthew over here. Matthew over here connects two envelopes. One of them is 1 foot long. The other is 9 inches long. So everyone, is it true that we have envelope number 1 being 1 foot long? Envelope number 2 is 9 inches long. Is that true? All right, great. Now, everybody, what operation do you think we should be doing with the foot and the 9 inches? What operation do you think we should be doing? Subtraction, multiplication, division? What do you think we're supposed to be doing? Right, addition is the most sensible option. And there's actually no conversion needed in this question. There will definitely be conversions needed in future questions, but in this one, no conversions needed. You might be tricked into believing that you have to convert units because you have 1 foot here, you got 9 inches there. Maybe they're trying to see how much you got left, what's the difference, but you gotta go with what the problem tells you to do. Everyone, when you are connecting two things, what operation does that sound like to you? When you're connecting two things, what operation is that? Adding. It is adding. And so I want you to understand, it is, yes, about converting units, but it's also about understanding what the problem is telling you to do. Remember that converting units is like a side piece in the solution process. The converting units is not it's not the first thing you should be looking at. The first thing you should be looking at is, what am I trying to do? Am I adding, subtracting, multiplying, dividing? And do I have to convert units to finish this? And so here we go. We are connecting them. We're adding them. 1 foot plus 9 inches. Everybody, is 9 inches enough to convert into feet? Is that enough? No, it's not enough. So 1 foot 9 inches. This is 1 foot 9 inches. Very straightforward, I know, but I wanted to lead off with that problem just to remind you guys that we have to be able to analyze these word problems before we get all gung-ho and start calculating whatever. We have got to be able to understand the question first. Yeah, and if you would have automatically assumed that you needed to subtract instead of add, you might have picked C, but that would have been wrong. So let's go ahead and try this next one out. This one's going to be a little better here. Let's go ahead and try this one out here. So here it says, how much wider? Again, the first thing we're going to do, read the Question. How much wider is Margaret's piece of string? Yeah, I'm here to teach you not to overthink. But it says, how much wider is Margaret's piece of string? Everybody, what does it sound like we're trying to figure out here? Again, just read just that red highlight. How much wider is Margaret's piece of string? So if I'm saying that, okay, this thing is this wide, this thing is this wide, how much wider are these two things? Like, how much wider is this one than this one? What am I trying to do here? Yeah, I'm trying to find the difference here. I'm trying to subtract. If I say that this one's this long and then this one is this long, well, I'm trying to find that gap between them. And to find the gap, or how much is in between, or how much space is in between, that's subtraction. That is taking a difference. Everybody, do we agree with that? Before we continue, do we agree with that? We're subtracting in this problem. Okay, great. So here, bam. If I want to know how much wider Margaret's is, we're going to go ahead and do, this string minus other string. Again, before I even read the question, before I read the problem and read the information, I know that how much wider, this right here, that's subtraction. That's subtraction. That's telling me to take the difference. That is telling me to take the difference every single time. That's telling me to take the difference. So with that, let's read the information. Let's see what we got to deal with, what we got to work with. So we have Margaret's piece of string right over here. Margaret's piece of string measures 1 foot 6 inches. So let me write this down here. We have Margaret's string is 1 foot 6 inches. And then we have Anthony's strings. Let me just highlight this. So Margaret's 1 foot 6 inches. And then we have Anthony's over here, 11 inches. Okay. Everybody, quick question. What did we say we were going to do with these two measurements of these strings? What did we say we were going to do? Yep. We are going to find the difference. We're going to subtract. So let me go ahead and show you a prime example. And this is, this is going to help us quite a bit here. But take a look at this. We have 1 foot 6 inches, and we're trying to subtract 11 inches. Everybody, can you do 6 inches minus 11 inches? Can you do that? Not quite. So this is where knowing how units convert, this is where it's going to be useful. So let's take care of business. Everybody, think about it like this. 6 inches is not enough to have 11 inches subtracted from it. Everybody, would you agree with me if I said, hey, if I turn that 1 foot into inches, I can just see how many inches I got total for Margaret and then take away the 11 from that. Is that something that we can do? Figure out how many inches, just convert all that just to inches. Just to inches. I don't know what this mess is with 1 foot 6 inches. No, I'm just going to turn all of that into just inches and then subtract. That'll be a lot easier on my mentality here. Let's try it out. Let's see where it leads. Let's see what we can do here. Remind me, everybody, if I wanted to turn a foot into inches, what's that conversion rate going to be? What's that conversion rate going to be? Yeah, 1 foot is 12 inches. 1 foot is 12 inches. So let's get that going. So this 1 foot 6 inches here. Everybody, this 1 foot is 12 inches. So everybody, what's 12 inches plus 6 inches? 18 inches. I haven't been to the subway in so long. Watch come class tomorrow. I'll be like, man, guys, I just had to Man, best meatball sandwich. All right, watch. So here we go. We have 18 inches there. So all I just did at this point here, all I did was I turned the 1 foot 6 inches into just inches. So my party people, let me write that down again. 1 foot 6 inches. How many inches is that again? 18. Perfect. So we have 18 inches minus 11 inches. What's that going to be? 7 inches. And that will be B. 7 inches in that case. So did that problem make sense to you personally? Did this problem make sense to you? You know, we had measurements for this and measurements for that. We wanted to subtract, but we just had to convert first. We just had to convert first before we could do the subtraction. So again, remember, you're not always looking to convert units. Like you don't like not every problem is going to require you to convert units. Not every single problem will. Some can be done straightforward. Some can be done with some intuition. But some don't even require you to convert units at all. This one did. You had to turn the feet into inches to see the difference in total. So Aliyah, that's a mathematical fact here. And Akila, that's absolutely correct. It absolutely depends on what the question is asking you to do. And Glenda, great question. So everyone, let's go ahead and take a look at both of these questions and look at the difference between, hey, in the question before this one, we added. In this question here, we subtracted. Why is that the case? And that's where context matters. You have got to be able to analyze what the problem is asking you to do. So here's what I mean. Notice how it says, hey, how long will the connected envelopes be? So if we take a look at that, boom. If you're connecting two things, you're adding. And we did the addition, and it turned out we didn't need to convert. We didn't need to. In this case, how much wider? That's like saying, how much richer or how much taller is this person than the other? And I think with height, it makes a lot more sense. If I say, hey, how much taller am I than you? That might prompt you to take the difference of our heights, right? If you take the difference of our heights, you'll see how much taller I am than you. So that word, that suffix er, that tells you basically tell the difference: how much taller, how much richer, how much older, how much wider. All of those words with er at the end. When you're comparing one to the other, you're subtracting. You're telling the difference. So let me know if that makes a little more sense for you personally. And then Malik takes practice. Takes practice. Takes practice. Now, since it's 7:43, I know we'll be able to get through at least the next two. And I want to show you again another example of a fundamental question that you should be prepared to take care of. So let me show you this one next. Right? Perfect. Okay, didn't cut off. So here's another one there. My party people, I actually want to see you try this one out. And I want you to do your best. And if you're confused by the end of the timer, I want you to be ready to take a guess. Let's see if you can get lucky. Let's see if your intuition can take you there. And then we'll come back and we'll try this out together. So here we go. Let me start the timer. 2 minutes. I'll add a couple more seconds so you can get started. And there you go. Shoot for it. I'll be back in 2 minutes. Try it out. And when you're ready, type ready. And again, get ready to take a guess if you need to. Let's get started. And that is time, my party people. That is time. Go ahead. Take a guess if you need to. Take a guess. Let me know if it's a guess, first of all. And let me know if it's a guess so I know where we are in terms of how we feel about our ability to do this. Okay, all right, all right. Hey, Delilah, take a guess. Take a guess, Delilah. Go ahead, see what you got. Cool. All right, let's give it a shot here. So, everyone, let me again explain to you why there's a separation between like the pure math that you do and your ability to kind of analyze and complete word problems. So, first of all, if you were confused or lost, that doesn't excuse you from first starting with the question sentence. Again, the first step in any word problem, every word problem is let's understand what the goal is. What are we trying to achieve? Everyone, in a few words or one word or as straightforward and as simple as you can say it, what are we trying to accomplish here? What do we want to find? What are we trying to find? Go ahead, everybody. Jonathan, I like that reply there. You were the first one. I like that reply. I love it. Kai, love that. Landa, love that. Paul, not sure that's a little vague there. A little vague. Carmelina, yes, that works. Lewis, yes. Krishan, yes. Yes, Muhammad. Kayla, yes. Final prize, Damien, correct. Delilah, perfect. So I noticed that a few of you that said that you were confused or had no idea what's going on. Yes, we can absolutely still point out what we're looking for. So you're not helpless. And I want you to have that mentality. You can definitely figure things out. I got you. So, first step, right here in red, let me highlight it. How much should you expect to pay to ship the item? So, right there, how much should you expect to pay for shipping the item? So, first things first, when I'm writing what I want, I'm going to say, hey, cost to ship item equals blank dollars. I don't know what that is. I don't know how much money that's actually going to be, but I do know that I'm trying to find the cost of shipping this item. Cool. Now notice. And let me ask you this honestly. Please be honest. Who here started this problem off looking to see what conversion needed to be done? Be honest. Who here started this off by looking for the conversion that you need to do? Okay, so that's the problem. If you were confused, I can tell you right now, that's the problem. There's going to be, so let me just explain this from a perspective of experience. Those of you that have had plenty of experience, if you know that this is a unit conversion class, you're going to be keeping your eyes wandering for that conversion. And those of you with experience who have done this before, you know that, okay, cool, it's going to work out. But for those of you that are confused, if the first thing that you're looking for is the unit conversion, that's not going to work out because you need to first understand, hey, what am I trying to do? And when I try to do it, oh, do I need to convert? That's the perspective I want you to take. Because if the first thing that you're looking for is converting, then you're ignoring the story of the problem. We got to know what's going on in the story so we know how to act upon it. And yes, we will be converting. We absolutely will be. But we need to understand that what's prioritized should be the goal of the problem, the story, and then the actual math. So let's go ahead and see what's going on here. Step 2, let's look at what we want. Everybody, we're trying to ship the item. What information is going to be useful to figure out the cost for shipping the item? Well, anything that has to do with money and shipping, I'm going to highlight it. Anything that has to do with money and shipping, I'm going to highlight that thing. So let's follow along here. So it says here, you'd like to ship an item that weighs 1 pound, 2 ounces. Okay, cool. Let me write that down. I want to ship an item and it weighs 1 pound, 2 ounces. Let's write that down. The item weighs 1 pound, 2 ounces. Perfect. Sounds good. Next up, it says hey, the post office charges $8 for the first 12 ounces and then $7 per ounce thereafter. Okay, so let's write that down. It's very, very, very important. So it said, okay, first 12 ounces. Everybody, how much did it say for the first 12 ounces? Who remembers? Appreciate that, Mohammed. Yep. First 12 ounces, that's going to be $8. First 12 ounces, right over here. Let me actually write this down like that. $8. Okay. Then it says, after the 12 ounces, it said $7 per ounce. This is mighty expensive, but whatever. It is $7 per ounce thereafter. Yeah, they charge a lot by the ounce, I know, but there it is. So with that said, boom, you're good. But what we have to understand is how much is being charged. That's $7. So let's break this down for ourselves, everybody. We have 1 pound, 2 ounces. How are we supposed to break this up? Any ideas, everybody? Any ideas on what we're supposed to do? Akila, there we go. Oh, I love seeing that. Love seeing that. So Akila said, hey, we need to convert because this is all in ounces. Everybody, do you notice this? First 12 ounces, $8. After, it's $7 per ounce. So does it make sense to you, as the viewer here, does it make sense to you that I should probably figure out how much this 1 pound, 2 ounces is as just ounces? Does that make sense to you? That the conversion here is necessary. Like, I want you to see why the conversion is necessary, not just that we're doing a conversion. I don't want you to just see it that way. I want you to see why we have to do it. So because that's in ounces, oh, right here, that's in ounces, we need to make sure that we're dealing with the same unit. And so with that said, let's turn this together here. Let's go ahead and figure out what that is. So we have 1 pound, 2 ounces. Everybody, quickly, we should know this by heart. 1 pound is how many ounces? 16, perfect. So we have 1 pound, that's going to be 16 ounces. And then we have 2 ounces. So how many total ounces do we have, everyone? How many total ounces do we have? 18, perfect. So we have 18 ounces, and we are set. And we're good. And we're good. So with that, booyah, we see that we have 1 pound, 2 ounces. That is 18 ounces. Now this is the fun part. Now this is the fun, because like notice, or I'm gonna actually forward this later because I'm gonna point something out that's gonna be very important for you in the future. But everybody, the first 12 ounces, that's gonna be $8. Great, perfect, sounds good. Then it says 7 pounds per ounce after that. Everyone, how many ounces are we applying that $7 to? How many ounces are we applying that to? Yeah, 6. Because 18 ounces, that is going to be 12 and 6. The first 12, again, that's what applies to the $8. The first 12, that's what applies to the $8. So we're good. That's just going to be $8. And then after that, the 6 ounces that are left, it's $7 per ounce. The word per here means you're going to multiply. You're going to multiply this number by the number of ounces. Per ounce is take this and multiply by the number of ounces. We have 6 ounces left. Everybody, quick question. What is 7 times 6 going to be? That's going to be 42. So who here believes that, okay, great, we got 42? Awesome, man. Answer C, right? Answer C. Nah, it's not going to be C, right? It's not going to be C. No, because you have to understand the word problem. The word problem is you're trying to find the cost of the whole thing. You got to apply the $8 for the first 12 ounces and the $42 for what was left. You got to bring all that together. And the answer is not going to be C. Nope. You have to take these and you have to add them together. So we have the $8, $42, add those together, and that's going to come out to be 50 total dollars. And that's how much it's going to cost to ship the whole thing. So even if you got this wrong, even if you got it wrong, do you understand why you were close, but not quite? And I see some of the frustration there because I see that you guys are noticing, okay, I calculated, I may have stopped just a little short, or maybe I misinterpreted one thing a little incorrectly. But what I want to point out is this. Earlier, what I was trying to tell you is this, my party people. Notice how the unit conversion was one step out of the lot that you had to do. The converting, that was just one piece. That was one piece all the way down here. That was just one piece. And it's okay, Yaya. Yaya, it's okay. Because you got it right. It sounds good. So the thing is, unit conversions are part of the problem. The unit conversion is not the absolute solution. No, there's a process that you go through just like any other word problem. And it just so happens that you got to convert units while you're in there. That's it. So I want you to understand that unit conversions is going to help you go through the problem in the same way that knowing how to multiply, add, divide, and subtract fractions helps you when you see fractions in a word problem. Knowing how to convert units helps you when you have to convert a unit in the word problem. So I want you to really tune yourself to that direction, because I don't want you to see unit conversions as, oh, the moment I'm done converting, I'm done. No, it's a word problem. You got to know what you need to do for the word problem itself. The 12 ounces we did use. Yeah, the 12 ounces we did use because it was $8. Those 12 ounces, they tell us, hey, those 12 ounces, $8. What's left, the 6 ounces, it's $7 per ounce, and that's where you multiply. That's where you multiply. And the way that we got the 18 was taking the 1 pound, 2 ounces, and we turned that into ounces. Because 1 pound, 16 ounces, you still had those 2 ounces left over. 16, 2, 18. That's where we got that. So with that said, it is 7:59. And so with that said, we're going to need to look forward to tomorrow's class. So everyone here should at least be in the program trial or the full program, or have had a chance to do it. And I want to point you in the right direction to continue practicing this and try to get ahead of tomorrow's class. And I want you to really benefit from that. So with that said, let me go ahead and just take it to the end here, because I do need to go and make sure that I respect your time and mine as well. But for those of you that have not, again, heard about the program, let me go ahead and put this into the chat box for you. Right over here. Because, again, the program is essentially how my students raise their scores to get the jobs they want. And with the program trial, you can also get into tomorrow's class, tomorrow night, 6 p.m. to 8 p.m., where we're going to continue exploring these word problems and looking at the different directions that we can take. So I really want to see you there in part 2, because this is all going to come together. We're going to continue reviewing converting units, and we're also going to be applying them into these word problems. So with that said, if you're in the program, Unit 3 of arithmetic reasoning, you're going to see those word problems in there with some speed practice, worksheets, recorded lessons, everything that you need. And again, for those of you that are curious about the program and you've already had the trial, I can go ahead and hook you up with a nice discount code before you go. So again, if you've been in the program trial already, you know how useful it is. Or if you haven't had the chance to try it, I'm going to explain very briefly everything that you really get. So again, the point of the program is to support you every step of the way. And a big issue is not knowing when you're done studying or what to study to begin with. So in the program, if you follow this plan, watch, practice, master, you're good to go. You're good to go. So you can watch me in fun live classes. Over 450 recordings already available for you. It's all there for you. Number two, you get to practice with over 15,000 practice questions across the AFQT. So it's actually not just math, it's also word knowledge and paragraph comprehension and general science. And beyond that, you have practice tests available to you, speed drills, everything you need. And to master things, I make sure that you have access to your own personal progress book where you can check your progress and see how things are going when it comes to the math. And you can communicate with me whenever you have any questions. You can text me when you need help, and that's going to make sure that I'm putting you in a position to succeed regardless of what you're studying. So for those of you that have been in the program, I appreciate those comments that you have in the chat box. But remember that we have to continue making progress one day at a time. So if you have already tried the trial and you're sure that this is something that you want to do, let me hook you up with a little discount code. That way you are good to go. The program is actually very affordable because other programs like charge $200 a month or like $78 for 1 hour. But with me, you can get 24 hours of classes every month for just $60 a month. Everyday low price. So you can go ahead and do it that way. Or if you're trying to go ahead and shoot for the absolute highest score that you can actually take $150 off the full year of the program, or you can take $200 off the lifetime version of the program with these discount codes right there. But let me go ahead and put the discount codes, let me go ahead and put the full program link into the chat box for you right there. Or you can go ahead and again, go to asvab.info/classes, click sign up and raise your score. If you have an account already, just sign into that account and then pick a plan and sign up. Super straightforward. But again, if you haven't tried the program out completely yet, you can and have the option of doing the trial first. I want to make sure that this is for you. I don't want to take your money without you being satisfied that you know this will work for you. So with that said, my party people, Malik, I've been teaching ASVAB for 4 years now, going on year 4. So it's been a lot of fun, man. It's been a lot of fun, and I'm looking for a lot more years in this. So asking me to do one-on-one classes, it's a very common question. But the thing is, I support, right at this point, a little over 900 students in the program with a trial and the full paid one. So I want to make sure I keep it fair to everyone, that I can give my time to everyone. So I use that time to text people, to answer questions in live classes, and you still have that benefit of communicating with me one-on-one. Again, you can ask questions here, and you can text me one-on-one on the side. It all works out just the same. That way, you're not paying for just 1 hour and then that's it. You're actually getting support whenever you need it. You can text me whenever. Sounds good. Yeah, feel free to text me. I got you. Yeah. But yeah, that's right. Muhammad's a long-time student of mine. Yeah, Muhammad's been kicking butt, continuing to improve his English, getting promotions. Like, I wish I still allowed people to use their video, because again, we have trolls here, and those trolls make it impossible to give you guys more access to the microphones and videos. But Muhammad, I'm gonna actually let you use your video in tomorrow's class, because you've always been awesome, man. Hey, Malik, I got you. So I don't have auto and shop or mechanical yet. I do not. I've been focusing on what I can make 100% guaranteed able to pass with. And then once we have all this locked in, right now we're making sure that we can handle all the trial requests and working with more recruiters across the nation. We're actually working with a good bit of recruiters. I think it's like over 75 recruiters in just the Southeast region of the US now. And it's been getting better and better and better for us. So we got to make sure we can handle all the demand. And then once we have that locked in, we'll continue expanding. General science right now, we have 200, a practice test course with 200 questions in there. And that's what we have right now so far. Gotcha. I got your poll, excuse me. Yeah, Neek, let me know if that answers your question there. Hey, right on, Tashi. And Tashi, don't forget, go ahead and text me, okay? Text me, Tashi. That way we can get your ASVAB shirt or hoodie situated. Man, like that's, again, I'm not a worldwide figure. So when I look at that name, I'm thinking, okay, is the B silent? potentially, because that's typically how I've experienced that. But if you want to correct me, please correct me, because I want to make sure I respect your name. So let me know how to pronounce that correctly. Hey, right on, Muhammad. How's your family doing too? How's your kid, man? Because I'm sure they missed you. Definitely sure they missed you, man. I'm glad you're safe. Glad you're good. Oh, you're in Qatar. That's cool, man. How is it? I mean, it's hot as hell out there. I bet. Yeah, Kayla, that's actually correct. So when it comes to if you're looking for any job, most jobs require a general technical score, a GT score, and what focuses on that is the word knowledge, paragraph comprehension, and arithmetic reasoning. So those are the three main ones that most people have to focus on. But no matter what, everyone, no matter what to pass, needs to focus on those three plus math knowledge. Oh man, Mohammed, I heard the World Cup games were a crapshoot. That was insane out there. And sounds good, McCullen. Yeah, feel free to text me. I got you. Take your time. Take your time. I want to make sure that this is absolutely for you. And I want to offer these awesome discount codes. That way, again, when you're ready, you understand, like, I'm not doing this for the money. I really want to help you succeed. Yes, I have a living to support. Sure, it's a business, but I'm not here to try to steal people's money. Like, this is what I believe people should pay for a service like this, even though you're getting way more than you're paid for. And that's my business model. I want to make you happy to do business with me. I want to make sure that you know that you're always getting way more than you're paying for. That way there's never a question about what this is about. Malik, the hoodies are 30. The hoodies are $30. Yeah. And that's going to be at cost because it costs $26 to produce them, and I sell them for 30. So I only make $4 off of them. And that covers the cost of sending you the tracking information and all that other stuff. Yeah, the 60 a month is still a crazy good deal. I'm telling you, like people have been charged like 400. I think this one person got charged 720 for what was it, like it was 6 sessions. So 6 sessions of 1 hour. They never got any materials to work on after class. Like what? Why would you pay all that money to just get 6 hours of learning? That's not even a school week. And you pay that much money? Like if you do the math, you're paying almost $3,000 per month if you do it that way. It's not fair. So that's why I do it the way I do it. Make it simple, easy. I don't want to make it about the money. Just get in, start learning, raise your score. Yeah, Muhammad, I think you won one of them and then you bought the other, or did you win both of them? I forgot what it was. Hey, Malika, see you tomorrow. Yeah, that's absolutely right, Zero. Oh, you won both? That's right. You're robbing me blind, man. All right. So with that said, my party people, yeah, Kayla, hopefully you can text me there. But my party people, I do have to go ahead and step away for the evening. Health reasons, want to make sure I rest and get my rest. So with that, yeah, I'll go ahead and announce in tomorrow's class another way that we can win a shirt or a hoodie. But you guys all have a great evening. Muhammad, it's great to have you in class again tomorrow. I'll go ahead and let those videos fly. That way you can go ahead and show your face to everybody, because definitely appreciate you coming back, man. Landa, appreciate you. Keep working hard. Keep working hard. Keep working hard. One day better, one day at a time. So if you have any questions about the program, again, let me know. I got you. And I'll see you in tomorrow night's class, my party people. Let's say the ASVAB. Cheers, guys. It sounds good, Naili. I'll see you then. Text me if you have any questions. And so my YouTube party people, go ahead and let me know if you have any questions as well. Feel free. Here's my phone number. It is 567-698-8867. Again, anything you need, I'm your guy. I got you. And so keep up the party. There's my phone number. Do what you got to do to ace the ASVAB. And if you have any questions, again, just reach out.